Okay, so if you look at a hyperbolic paraboloid, which is made by rotating U line around an axis like that, and you could also, to get the angle precise, you could also just rotate this 15 degrees or something. All right, let me do 45 so you see how that works. If I rotate this 45 and then I move it off by a certain distance, and then I revolve this. Okay, that's how that works. So now these surfaces have normals and tangents as well. So if I draw a line and I click on this normal, I can click on any point and construct a norm. And that normal will always pass through the axis like that. And then if I take an isocurve at that point, I extract the isocurve. I could draw a tangent there from that point. And if I extend these edges, extend curve by line, extend curve by line, and I explode and loft these two together the right way, it'll make a hyperbolic paraboloid, which is tangent to them. Now that's only tangent, it's not truly continuous. By the way, if I take these surfaces, let me make a complete one. And I rotate them around one of their isocurves, one of these straight isocurves, 180 degrees, that will produce the tangent perfectly nested one like that. And they would share a normal at that point. So if I were to draw this one's axis, you would see that it is passing through that as well. Okay. But if I want to make a hypar that is truly tangent here, what I can do is I can take the normal, not truly tangent, truly continuous, even more than tangent. I can take the normal at the bottom here. And I can take the normal at the top, this isocurve. And I can rotate that around the axis 180 degrees. I mean, sorry, 90 degrees. And I can do the same here. That is also a tangent line, except it is not tangent just to the profile. It's tangent to the direction also of it's part of the plane that is truly normal there. So if I loft these two together, I'm going to make this 150. 80, 80. I loft these. That surface has a more perfect relationship with the hyperboloid. And actually, it also contains the mirrored isocurves. So these hyperboloids have two sets of mirrored isocurves. So if I take this isocurve and I mirror it about any point along it, I'm going to pick the midpoint and any 2 points on the axis, that creates its opposite isocurve, and both of those isocurves lie in the surface, and they both lie in this surface. So what I could actually do is trim this surface and replace those pieces of it with the pieces of this, and they would be perfectly matching. This is just because it's, if I were to rebuild this surface with degree 3 and a bunch of points, you would see it better. It's just because Rhino has sometimes trouble displaying the true mathematical surfaces. So that's this relationship here is pretty pretty beautiful and extraordinary. And you can go the other way as well. So if I have, and you can do it with all different shapes and sizes, they don't have to be the same. Like here's another one. Um, there's a different one. And if I start with the hyperboloid, with the hypar, instead of the hyperboloid, all I need to do is take its two isocurves and draw the normals from one set and the other, and draw the normals down here. And then I can connect those with an axis using my intersection snap, and I can revolve one of those around it. And that produces the same construction from the hyperboloid, from the hyperbolic paraboloid.